Hi everyone, today we are going to be discussing in secondary science methods assessment. And I recognize that you all take an entire course about assessment. However, it's really important that we discuss assessment in the context of science and also discuss alternative assessments from the ideas of quizzing and testing. And finally, some of us will be teaching grades that will be assessed through the Louisiana State LEAP exam, or LEAP 2025. So we need to talk a little bit about that as well. So today's learning objectives are to compare and contrast diagnostic, formative, and summative assessments, and also learn about and apply various ways to use both traditional and alternative assessments in your classes. So let's get started. First, as we have discussed in previous lectures, the Next Generation Science Standards, which are what the Louisiana State Science Standards were adopted from, is made up of three parts. You have the SEP, or Science and Engineering Practices, the cross-cutting concepts, and the disciplinary core ideas. And your assessment should include students being able to use knowledge about a science phenomenon and about related practices to solving problems in that context, answer how and why questions about the phenomenon, recognize what the students do not know, and also for students to be able to provide convincing explanations for answers about that phenomenon. So that's really what your assessment should focus on. Additionally, in science, assessments should be the process of reasoning from evidence, right? I mean, what is the whole point of science? You do an experiment, you get some evidence, and then you revise your hypothesis. So really consider the important critical components of assessment and how they're represented in the Next Generation Science Standards. For example, criteria specify the expected level of student performance. Well, in NGSS, criteria are not specified and often are not found instructional objectives written at the district or school level, but they must be targets of the assessment. So this is where we might be missing certain components. Also, performances identify what students should know or be able to do. The learning expectations of NGSS are not described in terms of observable behaviors. However, we can create assessments to observe specific behaviors to understand if our students have learned that particular objective. Disciplinary themes and goals highlight the desired educational outcomes for the nation's schools. Practices, cross-cutting concepts, and core ideas of science and engineering are foundational to the learning expectations of NGSS, but those might not always be what we necessarily see on state and district exams. So there's three parts for a successful assessment. One is setting expectations, two is observing student performance, and three is interpreting student performance. So we're going to go into each one in detail, and then I'm going to discuss traditional and alternative assessments. So for your students to be successful on an assessment, you need to set expectations. If you precisely word your learning objectives, it will be so much easier to measure if students achieve those learning objectives. Remember on our NIET rubric, we want you to explicitly explain the student learning objective or student performance for that day's lesson. If your students understand that they need to be able to recall specific terms, they need to be able to apply a concept to another phenomenon, they need to be able to read a graph and interpret that data and then identify which concept that data represents, then they can go forth and do that. I think the worst thing for students is when we have no idea what the teacher wants. And so it's really important that we explicitly explain that. Also, in the world we live in now, giving that student the sense of control in the sense that they understand and have explicit expectations placed upon them makes them feel more confident in their ability to actually proceed with that assessment, or at least be able to ask questions if they don't understand those expectations placed upon them. So here are two examples of very different expectations, and you can kind of see under the different learning conditions which one we normally favor when we're just starting out teaching versus once we really understand our content, where we kind of aim for. So I'm going to start with teaching and learning condition 2, which is the more common expectations we have for students, particularly in introductory courses. So the learning objectives are define plate tectonics and describe what happens at convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. And so the teacher's assessment is students will write a definition of plate tectonics and will submit sentence-long descriptions of what happens at convergent plate boundaries, divergent plate boundaries, and transform plate boundaries. Students will also list the names of the 6 major plates. Now, these are great student learning objectives for the beginning of a unit where you need your students to master the language to be able to then apply that language to a particular phenomenon that you present. But this is all recall. This is all lower levels blooms. What we would hope is that you will get to a point where you can have your students learn under condition 1. And these learning objectives are a little bit different and also very specific. Learning objectives include plot locations of earthquake epicenters and volcanic eruptions on a map, predict the tectonically active areas using data about the locations of earthquake epicenters and volcanic eruptions, and explain how earthquake epicenter and volcanic eruption data do or do not provide the support of the theory of plate tectonics. Now, first off, they're providing a phenomenon, and they're also explaining explicitly what they want to see their students be able to perform. So students will be given earthquake epicenter and volcanic eruption data, including data on latitude and longitude for a fictitious planet in another galaxy. They will plot the data, compare the data with the surface map showing plate boundaries for the fictitious planet, and assuming that tectonic activity on the planet follows patterns similar to those on Earth, explain how the data do or do not provide support for the theory of plate tectonics. Which one sounds more fun? I can tell you I would rather be plotting stuff on a map than learning the definitions. And maybe we still need to learn the definitions in this unit, but how much more fun and engaging is it to have teaching and learning condition 1 over teaching and learning condition 2, which we usually favor. Additionally, if you look at the state level exams like LEAP 2025 in Louisiana, they don't ask for recall questions. If they do, they might have a few. But what they want is more data analysis and more interpretation. So teaching and learning condition 1 would also better prepare your students for those state level exams. So here you see 2 very different expectations from 2 very different teachers. And then finally, we need to observe student performance. But where in the lesson do you plan to observe? You can observe your student performance in various parts of the lesson, including the beginning of the lesson. So you can find out what prior knowledge are you building off of, what do your students already know, what level of understanding are your diverse students bringing to the unit, what misconceptions will your students bring to the lesson, and this is which is something that I think is great at the beginning of the unit, because then you'll understand like what you're up against. I'm a really big fan of Paige Keeley's Uncovering Student Ideas in Science. She has a ton of formative assessment probes that you can use as bell ringers. You can also use them as exit tickets or in the middle of the lesson. But they're just terrific ways to see what and how your students understand various scientific concepts. And I think she's written a probe for every single next generation science standard. So, and a couple for each. So you have a variety that you can work with. If you're going to observe student performance in the middle of the lesson, which many of us do, you can ask your students to do something like jotting down a few key concepts. You could ask them to define terminology for you. You could ask them to draw a model of what they think will happen. So if you're presenting a phenomenon and then adding a variable to that phenomenon and asking them to make a prediction. And this is a formative assessment to help you identify if most of the students are understanding the lesson thus far. And this could be as easy as a clicker question. You could use a lot of educational technology so it doesn't take too long, but it's a great way to check in through your lesson and not just calling on that one student who has the right answer in the class. And then, of course, you want to observe student performance at the end of the lesson. Usually, it's a summative assessment of sorts, like a short quiz or an exit ticket. Or what I really love is the application of concepts to a new phenomena. So we just learned all about the bison and the Serengeti. Now, what if we introduce a virus or a vaccine or a new food to the Serengeti, and then have your students apply whatever ecological concept they've learned that day to that new thing? It's really important that we balance the types of assessment we use. Students will easily get used to an assessment, and then if you just randomly change it up, it kind of messes with their brains. So I highly recommend that you use a varied amount of different types of assessment throughout the semester. And before trying each assessment out, make sure you introduce that assessment and explain your expectations on your students before performing that assessment. So we all know about multiple choice, fill in the blank, true, false, and short answer questions that are included on paper and pencil tests, but that does not assess all that students are learning in your science class. And so I really love for you to consider using those assessments when appropriate, but also considering other assessment types as well. And please remember, as I sound like a broken record in this lecture, that LEAP and LEAP-like assessments are also really important. So the one we all know all too well is the science test. If you are going to provide your students with a science test, I highly recommend that you prepare your students to be good test takers. Discuss test taking tactics, give them practice questions ahead of time. They should not be the same questions that they will see on their exams, but maybe similarly worded questions. Also, consider the questions you write or use. First off, do they meet the learning objectives discussed in class? The worst thing you can do is go into an exam or a test as a student and not have any idea what exactly is going to be on that exam. Also consider the level of an amount of content that you're testing. For example, it is completely inappropriate to give your students a 50 question exam from 5 chapters. That's 10 questions from each chapter. If these are big honkin' chapters about DNA transcription and translation, or calculating molarity, and then figuring out the concentration of different things, I mean, really, what will your students know what to study from each chapter if you're only pulling 10 questions from each chapter? Please don't use double negatives in your questions, and do not do the is it answer A and B, answer A, B, and C, all of the above, none of the above. I mean, that is like playing mind tricks on your students. Also, be careful that you use the same wording on the tests that you use in class, which should reflect the wording that they would see on their state and district exams. So it's really great to give analogies when you're teaching science, and maybe using some fun, cute terms. But in the end, your students do have to understand the language of science, and they do have to understand the terminology and be able to see that same terminology on their assessments. Also, please don't have your students merely recall. Please have them doing data analysis and application of concepts to other phenomenons on your assessments. Consider some alternative assessments as well. For example, a concept map. A concept map graphically shows meaningful relationships among scientific concepts. Students can be asked to generate maps without assistance, or may be provided with a partial map to complete. I highly recommend in middle school in particular, as well as in lower level high school, that when you want to use concept maps, that maybe you do one as a class first, or give them a partially filled out one to fill in, and then slowly scaffold it in a way that they will start to concept map on their own. This is a great whole class and small group activity, but it's also a great way for your students to show you how they're connecting these concepts on their own as well. Another great assessment is drawing or modeling. Now, you all should know that modeling is an SEP in the NJSS. But drawing and modeling exercises are useful for assessing the knowledge of students for whom English is their second language, and for students who find writing challenging. I mean, how much nicer is it for your students to be able to draw you a picture or use some sort of manipulative to model what they think will happen next, or what is happening in that beaker, or what is happening on the playground, or whatever it is that you're teaching. Drawings can also be used to reveal students' knowledge before and after instruction. I'm a big fan of having students draw what they think is happening, then teaching the lesson, and then having them as an exit ticket redraw what they think is happening again. And so here's an example of a student where they have to draw the molecular level representation of a sequence of events required for salt to dissolve in water. And this is terrific. You can see how they're thinking almost immediately. Also, if you're grading this, you probably need a rubric, or you might need to be like they either do it or they don't do it. So this is a great formative assessment. You also could do an interview. An interview can be conducted with individuals or small groups of students and can center around a set of questions and constructs in advance or on the spot. This can be used both as a formative or summative assessment. So you could have your students explaining the experiment they did and their reasoning behind it, or explaining the data set they have and what it means. Please make sure that you use terminology correctly, and your students do as well. If you are going to allow for some code switching, make sure that they're still using science terms correctly, or can still define them, because it is really important that students be able to communicate comfortably with you. But we also want to make sure that if they see these types of questions on the LEAP exam or on a district exam, they can still answer them appropriately. Another great thing about the science interview is it teaches science communication. Students sometimes are good at writing science because they're forced to, but they don't necessarily know how to speak science. And with everything we have going on between COVID vaccines and genetically modified foods and everything else, it's really important that we teach our students how to effectively communicate science and be able to say these scientific terms and explain these concepts in ways that make sense to them. One assessment that I love to do, and I encourage this in my elementary educators and middle school educators, but also it's a nice way to keep your high school students organized, is a science journal. And a journal may include your responses to questions that are given by you. So these could be like all the bell ringers and exit tickets for these students. These could be questions written by students that they wish to have answered. So instead of collecting exit tickets of things that they're still curious about or have questions about, you could just flip through their notebooks. It could be a reaction to class activity. It could contain their homework, and it could also contain spontaneous reflections. Like I said, this is a great place for bell ringers to be kept. And also, if they do keep a science notebook in your class, this could be where they could use to review before exams. And also, you can use the science notebook to kind of look at trends. So if folks are not doing so hot on your exams, you can go back through their science notebooks and see if there were any red flags or indications that they were not prepared for the exam. Something we discussed last week was the KEWL chart. It's a play on the KWL chart, but you can have your students work on this throughout the lesson and put it in their journal or turn it into you. The K stands for what we think we know about the phenomenon. The L is what we think we are learning. E is the evidence from our data. W would be your wonderings, and S would be the scientific concept and words that the students need to learn. This is a great graphic organizer that can really help your students. Oh, the lab report. How many of us have had to do a lab report before? If you are going to do a lab report, please scaffold the assignment. And it's all going to depend on the grade of how you're going to scaffold it, and like what we're preparing our students for. So for example, if your students are going to be doing a science fair, you would probably want them to understand the traditional lab report and walk them through the various pieces of that, including the purpose, the materials, procedures, data interpretation, and conclusion. And you would need to help them learn how to write scientifically all these pieces of the lab report. Now, there are alternatives to the traditional report, and that's the narrative lab report. These are very appropriate for middle schoolers, and they're also very appropriate for students when you're just getting them comfortable with the idea of writing up their lab reports and experiments. So rather than having your students just fill out worksheets when they're doing their experiments and their different lab activities, you could have them create a narrative report. That could take the form of a letter to a parent or friend in which the students describes the lab experience. And you can have them follow questions or prompts to help them write, including what was I looking for? How did I look for it? What did I find? And what does it mean? And then what you can do is using that narrative lab report, you can scaffold up to what was the purpose of this experiment or this activity? What did I use in this experiment or activity? How did I do this experiment or activity? And then what's my data from it and how do I interpret that? So I think, if you're teaching middle school, you can definitely use the narrative report in 6th and 7th grade and then graduate them closer to a more traditional report in 8th grade. Additionally, if you are teaching science in high school, if you are teaching college-bound students, you really need to have them be able to understand at least the pieces of a formal lab report and have all written a couple pieces of a formal lab report before they get to college. Because we all know in biology and chemistry, the expectation is that you will be writing those lab reports. Another alternative assessment is the oral presentation. Oral presentations involve students speaking on topics about which they have developed expertise. Organization, knowledge of the topic, and preparedness are among the criteria that you need to consider when evaluating oral presentations. I am a big fan of you all using rubrics and sharing those rubrics ahead of time with those students and also showing them examples of your expectations. Students should be able to practice making Prezis and PowerPoint presentations in high school because if they are college bound, that's what they will be doing. And additionally, again, you're giving your students the opportunity to practice speaking science, which is just so important in the realm of science communication. You can also assess your students through performance tasks. This is great for early in the semester as well as at the end of the semester. I like to do this around lab safety as well as understanding how to use lab equipment. It often involves the students manipulating materials or equipment in an authentic laboratory or field context and can be used to diagnose and monitor students' developing competency. So examples would be using a microscope correctly, weighing a reagent, lighting a Bunsen burner, identifying anatomical features of an organism, identifying specific organisms, or lab safety overall. I've seen this done really well in chemistry courses in particular, where early on in the semester, the instructor will have the students practice weighing reagents, lighting a Bunsen burner, measuring liquids, mixing liquids, and following specific protocols. And that way, when the instructor feels like their class is competent enough in those performances, then they can move on to really fun experiments. It's also a great way to keep your students safe and accountable if you just let your students go in the lab without having them have to quote unquote pass a performance task assessment, then they would just run wild. Another alternative assessment is the portfolio. You all are going through the Nichols State Teacher Education Program where we have both our undergraduates and graduate students maintain a portfolio. Portfolios are terrific for parent-teacher nights where you can show off what your students have been doing. A portfolio may include items that make use of many of the assessment formats described before this slide. So you could have your students keep a journal in their portfolio. They could have their presentations, their lab reports, that could all be in this portfolio. And this could provide the ultimate study guide for a LEAP 2025 exam. If you want more information on portfolios, because I do understand that feels a little bit more abstract to many of us because we never worked in portfolios until we got to college, check out this website, which has some really terrific suggestions on how to use portfolios in science classes. And here's one that wasn't in your textbook, and that's data analysis and graphing. Provide students a data set. Just find some data. If you need help finding data, I will help you find data. Have them graph the data. Have them look at data tables. but not just having them look at data tables and graph data, but also have them interpret what the data means based on the phenomenon presented, and then describe their data analysis. This is so important for the LEAP 2025 exam. You guys all have to do CERs, which is claim, evidence, and reasoning. That's where students have to make a claim, and it should describe the relationship between the dependent and independent variables. Then they have to use scientific data to support the claim or evidence. And again, if your students know how to look at a data set and interpret data, then they can make a case for the evidence. And then reasoning is going to tie together the claim and the evidence. So it shows how and why the data count as evidence to support the claim and provides the justification for why this evidence is important to this claim. So again, it's going to explain the phenomenon. So please have your students practice CERs or claim evidence reasoning. They will see it throughout their lifetime in Louisiana public schools. And it's really important that we prepare them well for this. But also, as an adult, don't you want to be able to look at a data table and be able to understand if the claim that's being made is correct or not, and then understand the evidence being presented and make their own reasoning? So we've done all these different assessments in our classes, right? Bell ringers, exit tickets, multiple choice exams, oral presentations, CERs. Now we need to interpret our student performance. My first recommendation is that you blind your assessments. We all carry biases with us, and it's really important that we take the names off of these assessments and grade them as blindly as possible. You also need to assign meaning to the data, and that really requires you to think about the data in terms of what was the student learning objective, and often through the lens of an instructional objective based on standards or curriculum framework. So again, we have to look at it through the Louisiana State Standard framework. And then you need to assign meaning to the data, and that also requires the consideration of the kinds of data that various assessment tools can provide. So when you're assessing test data, look at the average, look at the range, look at what most missed questions were, what objectives were missed the most. Was it how the question was worded? Was it the question type? I'm a big proponent of the 50% rule. If over 50% of your students miss that question, that usually means that the question is a poorly worded question, or you did not do a good job teaching that concept for them to answer that question correctly, and it should be thrown out. Also look at what's mostly corrected, mostly correctly answered questions. Like, are they only recall only? Maybe your students really understand the definitions of all this terminology, but they can't actually apply those terms to describing a phenomenon. Is it the different question types? Maybe your students are rocking out on their essay questions, but they're not doing so hot on their multiple choice questions. And then you can start to investigate what that really means. Also look at your English as second language learners, your students with disabilities. Are they all missing specific questions? And why is that? So you really need to think about how you're assessing your test data. When you're assessing narrative data, so narrative data is data generated from laboratory reports, essays, projects, performance data. It's made so much easier if you use rubrics or checklists. I am such a huge proponent of rubrics. You know that because I present to you every assignment and the grading rubric along with it. It also helps your students because it provides structure for assigning meaning to narrative and performance data, and it facilitates the process of making implications from the findings. If all your students are missing particular points on the rubric, then you can address that and you can start to think, is that because I didn't teach them how to do that? Or is that because they misinterpreted the assignment or the assessment? Make sure you go over the rubric after explaining the assessment and teach students how to read or interpret rubrics so that they can do it on their own as well. Also, as a student yourself, how good does it feel to see the rubric ahead of time and understand the student expectations that are put upon you before you're about to do that assessment? If you're having trouble making rubrics or you don't even know where to start, I highly recommend you check out the website Ruby Star. It's a little clunky, but what's great is you can peruse other people's rubrics and then you can create your own and download it into a Word or PDF document and you can edit it away. And I really love Ruby Star. It's a very easy way to create rubrics. And then as you become more and more experienced as educators, you can doctor up that rubric and change it as you need be, because you might realize that that rubric doesn't necessarily measure the learning objective you have at hand. I also wanted to introduce you to this idea of specification grading in this lecture, and I'm introducing it to you because there's a major push for it in STEM. And the way specification grading works is you pull out the major student learning objectives for your course or that lesson. And students are graded on a pass-fail on individual assignments and tests or on bundles or modules of assignments and tests. So when we're talking about bundles or modules, we're talking about scientific units. So if you have a bunch of assessments within a unit, each assessment would be graded on a pass-fail level. Then what you do is you provide very clear, detailed specifications for what constitutes a passing or acceptable piece of work. And this should be like a B or higher level piece of work. So this should be, what are your expectations to pass a oral presentation? What are your expectations for passing a quiz, for passing a test, for passing all sorts of different assessments like concept map? Then students are allowed to at least one opportunity to revise any unacceptable pieces of work or start the course with a limited number of tokens that they can exchange to revise or drop unacceptable work. So your students can have at least one chance to revise work or retake the quiz or the test to pass again. And then what happens is you as the teacher decide, all right, for you to earn an A, you have to pass 8 out of the 10 assessments that I provide in this unit. And a B would be 6 out of 10, and a C would be 5 out of 10, or however you want to do it. But that's how you would do specification grading. What's really nice about this is students don't have to stress if they're having a really bad week, if they have a really bad, if they have a play coming up, a major athletic competition, and they don't have enough time to study for that major exam. They know that they can have a second chance on it, but also maybe if they're well organized and they know that they have these major things coming up in their lives, they can then focus on other assessments prior to that major play, athletic competition, whatever it is that might be coming up. And then that helps them become better organized adults, as well as alleviates the stress on their mental health. If you're interested in specification grading, definitely check out this website. It explains it. And also, there's a lot of terrific textbooks out there on specification grading as well. So to wrap up, consider how you will prepare your students for ACT, LEAP exams, and the assessments in your classes. Choose your assessments wisely. Really think about it. Do you always have to give the exact same bell ringer and exit ticket type assessment? Do they all have to be multiple choice quizzes? Do they all have to be essays? I mean, really think about the types of assessments that you're using and how they match the student learning objective. Please make sure you set your students up for success by explicitly explaining what you expect from them, providing rubrics and grading criteria, and providing practice for different test question types. And finally, make sure whatever assessment you use that you analyze your assessment data and make changes accordingly to how you teach those topics, as well as to those assessments for future classes. Thanks, y'all. I hope you have a great night, and thank you for listening.